Thank you for joining the webinar. This webinar is brought to you by Samsung Electronics to discuss the new horizon of LED lighting. My name is Elio Jin-Ha Kim, and I'm responsible for lighting LED product marketing and application engineering at Samsung Electronics. I have prepared a really cool story about creating a cozy awakening lighting. That doesn't really have to be coolest in the correlated color temperature. Let's find out more. Okay. Let me start by asking a question to all of you. Here are two different correlated color temperatures lighting, 4000 Kelvin and 5000 Kelvin, the latter being cooler in visual perception. Which CCT of lighting would you prefer for concentration? I mean, for tasks requiring sustained focusing. Many of you must have chosen 5000 Kelvin lighting for better concentration because you're aware of the common knowledge in lighting design. Cooler light makes you alert, improves your cognitive capability to become more productive at work. Well, I can give you a list of research reports and papers from academia and government agencies on the effect of the lighting conditions to the learning abilities, performance, and vitality of the subjects. Every one of them ends up with the same conclusion, that blue-rich cool white lighting promotes such functional aspects of humans. Then, what's the reason we don't see as many 5000 Kelvin or even a cooler color temperature like 6500 Kelvin indoor lightings for offices and schools as 4000 Kelvin lighting? I think it's simply because they weren't very visually pleasing. The color of light is, of course, not the only factor that affects your concentration level or performance. According to UK's Health and Safety Executive, work requiring perception of detail needs 200 lux of illuminance on average, while for work requiring perception of fine details needs about 500 lux on average. Okay, then why don't we just brighten the space as much as possible? I think it's because the brighter the room is, the more glare and discomfort it causes to your eyes. In addition, what about the energy consumption? It, in most cases, doesn't make sense to just brighten up the room. The amount and type of lighting directly affects not only concentration, but also appetite, mood, and many other aspects of daily life. And you don't want to sacrifice all the other aspects just to boost your concentration level. After all, it doesn't seem that I can catch two rabbits at a time. A cozy, awakening lighting. Well, but what about this? Please look at these two pictures on the slide. These two pictures look identical at first glance. Okay, maybe you can give it a second glance with more focus. Actually, you might not see any difference between these two. Is this a trick or something? Well, in fact, this is the lighting experience room where we conducted an extensive clinical test through almost a year. We compared the participants' concentration level by giving them the D2 test, a standardized concentration level test. And the subjects group under the lighting condition on the left-hand side scored 3% higher compared to the lighting condition on the right-hand side. Well, this is quite remarkable, even though this was something that we had expected. In order to make sure, we double-checked by giving them Sudoku puzzle test as well. Surprisingly enough, this time the gap enlarged to 10%, with the same advantage to the lighting conditions on the left-hand side. Well, why is that? What makes this difference? Here's the key. It is actually because what you visually perceive doesn't really completely deliver the hidden information from the two different lighting settings in the two pictures. Overall, these two spectra look pretty much the same, except this shorter wavelength region. You can probably recognize that this one on the left-hand side has a prominent second blue peak near the cyan region of the wavelength, while you have a much smaller conventional 450 nanometer blue peak here, whereas the spectrum on the right-hand side has a strong conventional 450 nanometer blue peak together with a trough across the cyan region of the wavelengths. Okay, now we got some clue, but as long as these two spectra have the same balance between red, green, and blue, they visually appear as the same color. I think now we have another set of tuning knobs of the lighting, the spectral shaping. This is how we created the energizing lighting spectrum of LM302 and they. Okay, then let's continue on how to characterize the spectrum of lighting in terms of the non-visual stimulus that creates the awakening effect to human body. For this purpose, we make use of the melanopic sensitivity curve, which has the strong peak around 480 nanometer. On the other hand, conventional visual stimulus is most sensitive around 555 nanometer, given by the photopic sensitivity curve. Actually, this is very familiar to all the lighting engineers in most cases. This curve is the weighting function for lumen and lux calculation. The melanopic sensitivity curve gives us the melanopic lux. Here, the ratio between the melanopic and photopic illuminance of a given light source is called MP ratio. If a light source has a spectrum that gives high MP ratio, that spectrum can be called an energizing lighting spectrum. And if it gives a lower MP ratio, it could be a relaxing lighting spectrum. The awakening effect of the light is related to the suppression of melatonin hormone due to the light exposure of a subset of retinal ganglion cells. And this is this great discovery of the circadian entrainment. Professor Robert Lucas pioneered this research area and made a tremendous contribution in this study. So I can't really wait to interview him today, but let me finish my presentation just to do that. Well, LM302 and they is built with dual blue dyes in a single package, one at conventional 450 nanometer and the other at 480 nanometer. The addition of the longer wavelength blue peak directly increases the MP ratio of the spectrum by 20 to 30%. As you see in the view graph, we have a variety of CCT range, and we can see that the MP ratio is higher by 20 to 30% with LM302 and they compared to conventional white LED of the same CCT. By making use of this LED, you can build a lighting fixture that gives 20 to 30% higher melanopic EDI than conventional white LED. Melanopic EDI or MEDI is the abbreviation of melanopic daylight equivalent illuminance. It's a metric that shows how effective a light source is in suppressing melatonin, the scale of the equivalent illuminance from the D65 standard light source, daylight light source. Well, let's go back. Let's take 4000 Kelvin CCT as an example. Looking at this graph, at any illuminance level, you get 24% higher MEDI from LM302 and day compared to conventional white LED. In other words, you don't really need to make the lighting exceptionally bright, unnecessarily bright, to achieve a certain MEDI target for lighting design by making use of this new spectrum. Now, I'm going to take an example of a use case where we try to conform to the well building standard. Circadian lighting design section of well version 2 dictates that maximum 3 points are awarded for lighting threshold of 218 MEDI for all spaces except dwelling units. Please be careful here that the lighting level here is defined on the vertical plane, not on the horizontal workplace. This is important because what matters is the amount of light that falls on the pupils of your eyes, not on the work surface. I measured the vertical and horizontal illuminance in my office by myself and found that the vertical illuminance was roughly half to 70% of the horizontal illuminance. However, it may differ case by case. Here's the lighting recipe in this case. Let's assume that the vertical illuminance was designed to be 300 lux. MEDI requirement of 218 lux can be met by LM302 and day from 4000 Kelvin and above, while the conventional white LED can meet that criterion from 5000 Kelvin and above. If you see this graph, now you understand what the question was asking actually at the beginning of my talk. Well, in this graph, you see the height of the blue bar at 4000 Kelvin is higher than the gray bar at 5000 Kelvin at the same photopic illuminance level. You may also maximize the energizing effect of the lighting by making use of the higher CCT options from the LM302 and day as well. Okay, then what if you decide the CCT of the lighting first? You can find out the minimum required illuminance that meets the 218 MEDI threshold. You see that LM302 and day allows about 50 lux lower vertical illuminance than conventional LEDs throughout the CCT combination from 3500 Kelvin, 4000 Kelvin, and 5000 Kelvin. So it's actually about 70 to 100 lux difference on the horizontal plane, which is a great benefit. You may avoid an unnecessary bright lighting design or take the advantage of less glare by making use of this new spectrum. While the LM302 and day comes in the industry standard 3030 package, which is widely used for lighting fixtures, We also developed a day LED that comes in 2035 9-volt package. It'll address the needs for the human-centric lighting bulbs, which can be more easily accessible to general public or by the consumers, I mean. Yet, you may still question the viability of this new spectrum solution because the human-centric lighting still has to be competitive in the general lighting market. It's not only the highest MP ratio, but also all the other figures of merit that matters for the human-centric LED to become a practical lighting solution or component to be adopted by the lighting companies. So we have carefully tailored these 5 metrics of the LED: MP ratio, efficacy, and lifetime, and the color rendering index, and the eye safety represented by the blue light hazard. Okay, so these 5 metrics have been compromised and optimized to address the needs from the lighting market, and these are fine-tuned to the level that can be accepted by the lighting industry without much hesitation. Well, let me conclude my talk by making an emphasis on this one thing. You can stay alert and focus on your task by getting some help from the energizing lighting spectrum. In doing so, you don't always have to push the CCT to the coolest end. You always augment the cyan portion of the lighting without really noticing it. Well, actually, I can show you that not only this cool white, but warm white LED can be showing pretty significant portion of cyan region of the spectrum. I have this small spectrometer that works immediately as I make a measurement here. All right. On the right-hand side, I have the LM302N day tuned at 6500 Kelvin, cool white. And you can see from this screen that the cyan portion of the spectrum is very prominent, and we have a much smaller conventional blue peak. So most of the blue energy is shifted from short wavelengths to the little longer wavelengths here. This is quite natural, and this gives a very high MP ratio. On the other hand, I can still show you from this warm white LED, LM302N day, 3000 Kelvin. Now I will make a measurement of this spectrum. As you see here, even though this is a warm white 3000 Kelvin LED, you still see a prominent peak around the cyan region and a little smaller peak on the conventional 450 nanometer. So, you know, by making use of this new spectrum, you can create what I said, a cozy awakening light. This is interesting, isn't it?